Hi, my name is Paweł Rozlach, and I'm going to give you a short presentation about the development environments project and the progress that was made. On the screen, you can see that I already created an image that we will be using in this presentation. The creation of the image is automated up to a point of having a CI that will be automatically creating images on every push to the repository. The automation is done by Ansible. Now, apart from that, I also prepared a script that creates virtual machines with development environments for developers. It's very simple interface. So basically, we only provide the branch that for backend and for UI that the virtual machine should be built from, and a zone if the default one in Europe is not what we're after. So generally, we should try to minimize the latency. So the closer the VM, the better. So let's create the VM5. We'll be using different default branches to keep things simple, but this can be any branch. And I will give some more context about the branches later when we got to the booter tool. Now, the instance is booting. So let's try to log in. Oh, its SSH is not yet read. So while we wait, I would like to only point out that some of the activities here will take a long time. So I took a liberty to tend to post-process the video, and at some point, some of the parts of the video will be sped up. You can follow the real time in the bottom right corner and to get a feeling how much the given part of the bootstrapping really took. So we're in, okay. And now the multi-D already gives the developer some useful information. So first of all, we need to add this into etc or hosts on our laptop. I've created a tool that gives some better overview for developers, what exactly is happening and at what stage the machine is currently when it comes to bootstrapping the environment. The tool is divided into stages, like executes in stages. So here we have like networking information addressation, WireGuard UAI, bootstrapping, verification of branches, and etc. etc. So these are all important informations that developer may need. Once the tool reports that the machine is ready, the developer can start using it, but more about it later. First, so while we are at it, it's important to note that that the tool itself also does some sanity checks, so that developer does not have to debug things on their own. So, for example, the branches that we've passed to the tool during creation of the virtual machines are verified if there are indeed containers built for these branches. If they are not, the tool will fail and we refuse to continue. So this prevents a situation when we have container pull back off, and we can be sure that any later stages can indeed succeed. So apart from that, just also tools suggest that one can follow the bootstrap process more closely by using rule-noctl tool. So let's log in. that's number 5, sorry. So developer machine is already set up in a way that you can sudo to any user, and you can log in to develop, and you don't need to manage keys. The GCE does it for you. So as long as you have enough privileges on GCE in our Obstrace development environment, you're good to go. You don't have to worry about anything. It's done automatically. So let's try -u booter. The service is called booter, and as you can see, it does various things like starting GDK, warming GDK app, setting password, etc., etc. The tool is written in Go, and you can see it in the repository. So it takes some time. So maybe I will show you the repository in the meantime. As you can then here you will be able to see our VM, but GitLab.org Obstrace the VMs. So this is our so this is the repository. And I also share my notes, what's still to do, what's not, and it's not everything is polished yet. So there are 2 bugs, or bugs or to do if you prefer, that I still need to take care of, and some automation left. More about it at the end of the presentation. But here also you have Ansible playbooks and the booter itself. The booter is divided into like the system part that does all the activities like bootstrapping GDK, creating tenant, waiting for all the controllers to get ready, etc. And the user ops, which is basically the presentation layer that we see here. As you can see, the kind cluster is creating. So here in the logs and here in the booter tool itself. So in case something goes wrong, the systemd will restart the booter, and the booter will try again. The booter is independent, so if there was transient error like network glitch or like record history was temporarily unavailable, booter will retry, and it will also try to give you helpful error message, what went wrong in which exactly place. So what can you do to maybe fix it? But the main idea with which this system was designed is to keep it simple. So if you break it, just create a new one. It's meant to be fixable by provisioning a new machine. Now, the machine itself, maybe a few words while the system is still bootstrapping, is a bit over provisioned. So in theory we could fit into a smaller machine. So like a smaller machine in the series is like 4 CPU, 16 gigs of RAM, but this is like a very tight fit. And so I've made a decision to pick a bigger machine so that we have some spare capacity, and so we avoid some weird timeouts and errors, and have some space for our developers to experiment in case they want to debug or maybe launch something heavier on the cluster. The drawback of this approach is that the bigger machine costs $200 per month if we wanted to run it continuously. The cheaper machine is only $100. It's up for discussion, just pointing it out. Now, let's see, maybe something already is available. While the booter is booting, we can already create a WireGuard. We can access the WireGuard. So here we have UI address, sorry. We have address, and it's worth noting that the tool itself randomizes passwords. So every time the VM is bootstrapped, there will be different passwords for security. So there is no such thing like all the VMs have the same password. Password is leaked, and we have a problem. No, passwords are randomly generated. And another nice thing about this system is that, one moment, 5,000. Okay. Certificates are self-signed. New client. I'm not sure, so I need to have a look why it wasn't, why I wasn't asked to log in. I need to verify this. Maybe it's an old session. I don't know, but anyway. So this doesn't, maybe this is a problem with WireGuard. Still, I need to debug it. So this is like something to do. But anyway, new client. Let's call it Piroslach. Now we need to apply the config. And we can download the WireGuard profile. Now with that we have a profile. So depending on the platform you're on, Mac, Linux, and what kind of distribution you're using, it may be a different way to import WireGuard profile. On Ubuntu, this is the command. It's already the profile is already activated, and we can already try to log into, for example, GTK. The two waits are ready for GTK to start and to compile webpacks and whatnot. So we get a bootstrapped GTK. Unfortunately, there is also a problem with GTK itself, because at some point during the bootstrap process it dies, and I need to debug it why. But again, another thing for my to-do list. But this is unrelated to the automation tool. This is like the problem with GTK itself, it seems. Now, again, the randomized password, sign in. GTK already is pre-configured, so observability feature is enabled, and OAuth tokens are created, and so on and so on. And kubeconfig is ready to be downloaded. So let's log into the machine. Here we have some information also about what the machine is, where the machine is, the IP, and whatnot. But anyway, and in order to download kubectl, we need to file home dev kubeconfig cp and export kubeconfig. So as you can see, it works as if we were, it works on the kubeconfig qk config get config view, I think. Yeah, as you can see, we are connecting to a remote instance and using Kubernetes cluster as if it was locally. So we no longer have a problem with a different architectures, ARM, X8, ARM, AMD 64. It simply works. And you can use telepresence and any other tool, because the latency, if you picked machine close to your location, zone close to your location, it's really small and it works really great. So let's get an overview. let's get an overview what's happening. So Gatekeeper is bootstrapping, so it will take some time before it starts. And you can see ensure GOB cluster is deployed, so waiting for cluster to become ready. 2 is waiting for us for cluster to get ready. Now the WireGuard also makes it easy to share between people. You just need to create a new profile and it works. Anybody can just download, and you can just give the password and username for WireGuard UI to product manager or on your colleague, and they can create a profile for themselves, or you can send them a WireGuard profile. They connect and they have the same access as you do to GitLab, Kubernetes, and GOB backend. Now, we need to wait a moment, so let's speed up a bit. Now, auxiliary manifests are deployed. So in order to make GOB tenant accessible, we are deploying MetalLB and making an VIP, creating additional load balancer service with VIP address that is accessible from the workstation, from the developer's workstation, and now it's being deployed. So daemon set is getting started. Now we are deploying the GOB tenant. I think this is the last stage, and again this is fully automated. Developer doesn't have to do anything. The GOB tenant is created with one exception. It turned out to be, so I'm not sure we should be automating the tenant creation using OAuth flow so that Gatekeeper creates it. So I think I would like to discuss it at some point, because currently Gatekeeper, apart from creating a GitLab namespace, also creates some Argus groups, and this makes automating this process difficult, because the booter on any other tool that automates this process of tenant creation needs to perform a full OAuth flow in order to be able to talk to Gatekeeper, instead of just simply creating some Kubernetes object. But again, this is something we can maybe want to discuss. For now, there's one very simple step for developer that they need to do once the bootstrap process is done in order to finalize the provisioning of tenant. We will get to this in the moment. Let's have a look where we are. Oh, so Jaeger is still deploying. Oh, Jaeger is running, so let's see if this was it. No. So booter is waiting for GitLab observability, the GitLab namespace to get ready, and let's wait a moment. In the meantime, here again we have OAuth tokens printed for developers' convenience, some additional information like how to copy kubectl. The kubectl is already prepared in a way that allows accessing from the developer's workstation, so exported from kind and IP addresses are adjusted so that developer does not have to. And and we're done. So we need to visit the provisioning page. We need to visit this URL in order to finalize the provisioning. So as I said, because of the way the Gatekeeper works, automating this part was pretty difficult. So I choose to have one small manual step for developer left. let's see if develop so means now let's see if let's see if GitLab develop Git GDK is still running. Yep, it died again. Let's start it because we will need it and accept the risk. We need to wait a moment for GitLab. So I'm not sure why it's happening. Like GitLab is because the tool verifies after starting GDK that GDK is running. Somewhere down the way, GDK is just stopping or giving up, and I'm not sure why. While we wait for GitLab to start, another thing that needs polishing is that there's some more work needed to because in order to be able to see observability UI embedded in GitLab, we need to access GDK or GitLab GDK using IP and not the domain. This is due to how DNS resolution currently works in the cluster, and it's on my to-do list. Oh, let's log in and let's see how the password is here. Oh, sorry. Wrong copy paste. Sorry, here. Just wait a little, and while we wait, we can already open. The tool also provides you with the link to the group that was chosen for observability. So this group is picked every time during the bootstrap, and then groups differ between machines, but for every machine the same group is but for each machine the same group is always the same group is chosen. So let's open this group. Oh, as we can see, GitLab Observability UI is already working. There is some data source configured, and now let's do some magic and let's open using UIP. Great, and now groups gitlab.org. Sorry. Oh, yeah. And you can see observability is already here, and just a moment, patience. It works. So developer gets out of the box GDK and GOB configured together with embedding working, so they can immediately start developing and working on it. So this concludes my presentation. I hope you liked it. There are still some things to do, but I think it's pretty usable by now. Let me know what you think, and feedback is very welcome. Thank you.